Hello class, today we're going to talk about adding and subtracting mixed numbers. But there will be a twist at the end of the lesson. So before we do that, let's review some integer operations. Since that's what we've been working on for the last several days, let's just kind of review that. Now the other day I told you when you see a problem like this, I want you to think about the entire problem as a whole and find out what's going on in that problem. So when we look at this first problem, you'll notice that everything is plus. So if it is addition, all we have to do is start combining things that are alike. So take, for example, here I have an 18. Do I have anything that could go with that 18? Yes, I do. I have a 5. Because they're both positive, I can add those together. So 18 and 5 make 23. Plus, and now we put the others together. So we've got a -6 and a -12 that could go together. When I put that together, I end up with -18. And now we do one subtraction problem. If our signs are different, we subtract our numbers. So 23 take away 18 gives me 5. And it's a positive 5 because the 23 has more. Now the second question, you'll notice in this particular one, we have some things that we've got to do. You'll notice there is one plus, but we have two subtractions. And we know that anytime we see a subtraction sign, we're going to change subtraction to addition and the next number to its opposite. Okay. The plus, I don't do anything with. I'm good. I'll leave it alone. But I come to the next minus and I change it to change that subtraction to addition and the 8 to a positive. Now I start combining like things. So I look here for the -11. Do I have any other negatives that could add together with that -11? And I don't, so I just write it down. Plus. Then I go to the 10. Do I have anything that can combine with the 10? Well, yes, I have a +16 and a +8 that could go with the +10. So 10 and 16 make 26, plus 8 more gives me +34. Now our signs are different, so we do one subtraction problem, and we end up with 23 for our answer. And it's a +23 because the 34 has more. Well, today what we're going to attempt to do is put our integer rules together with mixed numbers by the end. Okay, so that's where we're headed. So let's start off with fractions. The first thing I would like for you to do is draw me a picture of 5/8 so I can see what you know about fractions. Your picture will help me determine whether or not you understand its true meaning. So pause the video and draw me a picture of 5/8. Okay, so let me find out what you did. Okay, this is two examples of correct ways of representing 5/8. One way is the pizza picture. So we have a circle, you cut it into 8 individual pieces, and you shade in 5 of them. That's what 5/8 looks like as a pizza. You also have a candy bar method where we could draw a rectangle and we chop it up into 8 pieces, and again we shade in 5 of them. That's what 5/8 really means. It means take a whole thing, whatever that whole thing happens to be, cut it into 8 individual pieces, and you take 5 of them. Okay, so the denominator in a fraction means how many pieces it takes to make a 1. Okay, so in this particular fraction, it takes 8 pieces. The top number, the numerator, tells me how many of those pieces I have. Okay, so that's what we're looking at today, fractions and how to add and subtract them. So let's start off by looking at two simple little fraction problems. Now there are some steps that we have to follow in order to add, subtract fractions. So let's look at those steps and then we'll come back and solve these. What you've learned in the past in order to solve fraction problems is the first thing you must do is find a common denominator. You have to make the bottom numbers look alike. Make the fractions the same size. The second thing you do is you change your numerator the same way you did your denominator. If you multiplied the bottom number by 3, you've got to multiply the top number by 3, and so on. Once you've done that, all the hard work is done. Then all you have to do is add or subtract your numerators, keep your new denominator, and then last but not least, simplify. So let's see if we can do that with these two fraction problems. So the first thing we said was find a common denominator. So I'm going to rewrite my fractions as blank fractions, and I'm going to define the common denominator. What we need to do is find a common multiple that 8 and 12 have in common. So I take the 12 and I start going through the multiples of 12. 12 times 1 is 12. And I ask, can I turn the 8 into a 12 through multiplication? No. 12 times 2 is 24. Can I turn the 8 into a 24? Yes, I can. So if you needed to list out the multiples, then you do so. 12, 24, 36, and so on. And then 8, 16, 24. And we find out that they share that common multiple. And that becomes our common denominator. Now, most of you have been taught to find the least common denominator. And this method of listing multiples will do that. Another way of finding a common denominator is just multiply them together. 12 times 8 gives you 96. That will be a common denominator and it will work. It's just you've got more work at the end. Right? So now, step number 1 is done. Found a common denominator. Step number 2, change your numerator the same way you did your denominator. So this 8, how did I make it a 24? Well, I multiplied it by 3. So I do the same thing to the 3 and get 9. How do I change the 12 to 24? Well, I multiplied it by 2. So I do the same thing to the 5 and get 10. Okay, so all the hard work is done. Now we just add the numerators. 9 and 10 make 19. Keep the denominator and attempt to simplify. And 19 over 24 will not simplify. For subtraction, we do the same thing. It's just we have to subtract, except for add, instead of add. So we rewrite our fractions. 5 and 3, the first multiple they have in common is 15. How did I go from 5 to 15? Multiplied by 3. So I multiply by 3 on the 4 to get 12. How did I go from 3 to 15? Multiplied by 5. So I multiply the 2 by 5 to get 10. And then we subtract. 12 take away 10 is 2. Keep your denominator, and we don't have to simplify. Now what we're looking at today is what if I had a mixed number? What if I had 2 mixed numbers? How would my rules change? Well, our rules for regular fractions are find a common denominator, change your numerator, add or subtract your numerators, keep your denominator, simplify. Well, we have to add one step in if we're going to do mixed numbers, and that is add or subtract your whole numbers. That's what we got to look at. So let's see if we can do this mixed number problem. Again, the first step is find a common denominator. So I'm going to rewrite my problem so I can then have room for my common denominator. So I start with my 8. Could I turn my 4 into an 8? Yes. So the 8 happens to be my common denominator. Now I could have used 16, or I could use 24, and I could use several other numbers as well, but 8 is going to be the smallest. So how do I go from 4 to 8? Times 2. So times 2 to get 6. What did I do to 8 to turn it into an 8? Not a thing. So I just write the 5 down. So now we add. We've got 6 and 5, which make 11. We keep our 8, and we add our whole parts. 6 and 5 again are 11. So now this particular one is what we call an improper fraction. And yes, we must simplify our fractions. This will only get you half credit if you get this far. This shows me that you understand how to add mixed numbers. So now we got to simplify. And to simplify this one, if it's an improper, it's just a division problem. We say how many 8s are in 11. So if you can't do that in your head, you actually come over to the side and do your division. So we ask how many 8s in 11? 1. So what do I do with that 1? I put it into the 11. So it becomes a 12. And so then we just subtract the 11 and the 8. And once we take that 8 out, what do we have left? We have 3 left, 3 of those pieces. And what size piece are they? They are 8s. So this one is 12 and 3/8. So that's addition. So what would we do differently if we had a subtraction? The only thing we would do is subtract in the end. So pause the video and work this one on your own. Okay, let's see how you did. Again, first step, find a common denominator. With the 9 and the 6, I start with the 9. 9 times 1 is 9. Can I turn the 6 into a 9? No. 9 times 2 is 18. Could I turn the 6 into an 18? Yes. Now, how did I go from 9 to 18? I multiplied by 2. So the 7 I multiply by 2. How did I turn the 6 into an 18? I multiplied by 3. So I multiply the 1 by 3. And I end up with 3. Now what we have to remember to do, since this is a subtraction problem, is we have to remember to subtract. So 14 take away 3 gives us 11. 18 and 18 is the size of our fraction, so we keep the 18. And then 9 take away 4 is 5. 5 and 11/8 or 11/18 because you cannot simplify. And you're done. Okay, one more subtraction problem, and then we'll get into our twist. So what if I gave you this one? Okay, now this one poses a new problem. Okay, so we still do it the same exact way. We start off the same by finding a common denominator. So we end up doing 4. We rewrite our problem here. So we've got a 4 and a 3. So the common denominator will be 12. That's the first number they have in common. So what did I do to the 3? Multiplied by 4. So I multiply the 1 by 4. What did I do to the 4? Times 3. So times 3, you get 9. Now our problem arises when we have 4 take away 9. Well, we can't do that. 4 take away 9 does not work. So we have to remember what happens, okay? Like if I were to give you this problem, 432 minus 247, what am I going to have to do to subtract 7 from 2? And we'll have to go next door and borrow. Well, we got to do the same thing with fractions. Just the number next door happens to be a 4. So we borrow from the 4 and it becomes a 3. Now on this, I'm just going to show you the trick on what we do in order to find the new fraction. So I've got to borrow from the 4 and it turns into a 3. Well, I need a fraction that's got a 12 on bottom. That's not going to be big enough to subtract 9 from. So the trick is I just take these two numbers and add them together. So 12 and 4 make 16. And now I can subtract the 9/12 from that. So I do 16 take away 9 to get 7. I keep the 12. And I do 3 take away 2, which is 1. And we end up with 1 and 7/12. So sometimes we may have to borrow. Okay, so just kind of remember that. Now, for the trick, I told you at the beginning of the lesson that we might incorporate our integer rules with mixed numbers. So what if I gave you this one? Well, if you remember back to the very beginning when we reviewed our integer rules, if I were to just give you this much of the problem, the 18 plus -6. We had a rule in integers that said if it is plus, if it is an addition problem, and my signs are different, all we do is we subtract our numbers. So what we've got to think about when we have this fraction problem is what are those rules? First off, do we have an addition problem? Yes, but my signs are different. So what am I going to do with those numbers? We're just going to subtract them. That's all it amounts to. So now that we know that we're going to subtract these numbers, even though there's a plus there, we're still going to subtract them because one is positive and one is negative. We go through the procedure of subtracting. So now we've got 8 minus 3. Okay, we find common denominators. In this case, we have 8. Okay, no big deal. Okay, now, what did I do to this one? I didn't do anything, so I leave that as a 5. What did I do to the 2? I multiplied by 4, so I multiply the 1 by 4. And now we subtract. 5 take away 4 is 1. Keep the 8. 8 take away 3 is 5. And we end up with 5 and 1/8 is our answer. So the rules, all it does is it tells us what we're going to do with the mixed number problem. Are we going to add? Are we going to subtract? What are we going to do because of the signs? So one last question, and then we'll be done for the day. So it says, what about this one? Well, if it's a subtraction problem, what did we do when we did integers? When we had this integer problem up here, and we had a subtraction, what did we do? We changed our subtraction to addition, next number to its opposite. So we're going to do the same thing when we have a fraction problem. We go to a minus, we change subtraction to addition, next number to its opposite. Now we find out that both of our numbers are negative. So if my signs are alike and it's an add problem, what do? We add our numbers together. So, -5 with the fraction bar plus -4 with the fraction bar. We've got 5 and 4, so our common denominator will be 20. So now we change our numerators. So for this 5, I multiplied by 4. So I multiply the 2 by 4 to get 8. What did I do for the 4? I multiplied by 5. So I multiply the 3 by 5 to get 15. And now because our signs are alike, we're just going to add. So we have 8 and 15, which makes 23. We keep our 20. And now we add our -5 and our -4 to get -9. Now we have to simplify because it's improper. So how many 20s in 23? There's 1. So we add that into the 9 to get -10. We subtract those out. We get 3. What size piece are they? 20s. So we end up with negative 10 and 3/20. So in order for us to answer questions about mixed numbers, one, we do have to understand the rules for mixed numbers. We have to understand that we have to first find a common denominator, change your numerator, and so on and so forth. But sometimes we're going to throw in the integer rules on top of that. If it's a plus problem, we look for, are the signs alike? Add. If the signs are different, we subtract. If it's a subtraction problem, we're going to change subtraction to addition, next number to its opposite, and go back to our add rules. And that's how we add and subtract positive and negative mixed numbers. So until next time.